we're going to get started with the new unit, Unit 7, which we'll be working with more exponents in this. All right, and so kind of the properties of an exponent are that you have a base and you have an exponent. Okay, so that means that if I have a base of 3 and an exponent of 2, that means we're expanding this to 3 times 3. All right, so if I look at a number line, 5 to the first is 5, 5 to the second is 25, 5 to the third is 125. What's 5 to the 0? Anybody know? 1. Okay? Because if we're multiplying 5 each time this way, we're dividing each time this way, 5 divided by 5 is 1. What's 5 to the negative 1?
Negative.
Well, we're taking this number and dividing it by 5, right? So this is going to be 1 over 5. What's 5 to the negative 2? Well, let's say this. Let's kind of go to a separate place here for a second. All right, let's talk about division of numbers. Okay? So we all understand that if I have 42 divided by 6, what's that going to give me? 7. Okay? So then 42 times what number is going to give me 7? No, 42 times 6 is 254. Huh? 1 over 6. Okay? So really, if we are dividing by 6, that is the same thing as multiplying by 1 over 6. You understand that? Okay? So if I come back to this number line here, and I say, okay, well, each time we're dividing by 5, or we're really kind of multiplying by 1 over 5, then if I take 1 over 5 and I multiply this by 1 over 5, what's 5 to the negative 2? 1 over 25. Okay? So there's a rule that we're going to kind of set up with this. Okay? And that rule means that if I have, let's come back here for a second. If I have some number x and I raise it to a negative exponent, then that is the same thing as saying 1 over x to that positive exponent. You with me? So we've come back here to the number line. Look at this. If we see here that we have 5 over 2 is 25, 5 to the negative 5 squared, sorry, is 25. 5 to the negative 2 is the opposite, 1 over 25. Okay? So 5 to the negative 2 is the same thing as 1 over 5 to the positive 2, which is 1 over 25. Okay? So, we see here that a sandfly has a wingspan of 5 to the negative 3rd power. Evaluate this expression. So tell me, what is 5 to the negative 3rd power? It'd be 1 over 5 to the positive 3rd power, which gives me 1 over 125. Okay? All right, so you guys evaluate these. All right, Mike, what did you get for the first one?
1 over 64. 1 over 64.
1 over 64. Sophia, what did you get for the next one? 1. Lauren, what did you get for this one? No?
No. I got 1 over 695.
No, that's fine. 1 over 625. Well, what's the answer for this one? Huh? Negative 1 over 625. Okay, now let's talk about the difference between these two right here. Okay, the difference is on C, on this one right here, the base for this is negative 5. The exponent is, of course, negative 4. For this one, this is the same thing as saying negative times 5 to the negative 4. Okay? The base for this is not negative 5. Unless I put that in parentheses that indicates that that negative goes with the 5, okay? This is saying negative times 5 to the negative 4. And if 5 to the negative 4th is 1 over 625, and we multiply that by a negative, we have negative 1 over 625. Okay? So make sure that when you're talking about negatives, if it's in a parentheses, you let that be your base. If it's not in a parentheses, just the number is in the base when you're evaluating these. All right, let's do it again. All right, Nicole, what did you get for the first one? Okay, 1 over 10,000. DJ?
Negative 1 over 10.
Negative 2 to the negative 4th is the same thing as 1 over negative 2 to the positive 4th. Right? And so negative 2 times negative 2 times negative 2 times negative 2 is going to be positive 16. Okay? Now, trick here. If I have a negative number for my base, if the exponent is odd, the outcome will be negative. If the exponent is even, the outcome will be positive. Okay? All right. So we get negative 1 over 32. Lauren? I'm asking you.
Oh, I don't know.
All right, so negative times 2 to the negative 5th. So that's negative times 1 over 2 to the positive 5th. So that's negative times 1 over 32. Because this is an odd exponent. Okay, so this is saying I have a negative times a negative times a negative times a negative times a negative, right? So these two make a positive. This positive times this negative makes it negative. This negative times this negative makes it positive. And this positive times this negative makes it negative. Okay? All right. And again, calculators are incredibly useful and allowed. Okay? All right. So we can go ahead and skip here. Let's go ahead and start plugging in some values here. All right, so you guys go ahead and do this one. All right, so here we have negative 2 times 5 to the 0 times negative 3 to the negative 4. So we have negative 2 times 1 times 1 over negative 3 to the positive 4. So this is going to give me negative 2 times 1 over 81, which would give me negative 2 over 81. All right. We're gonna skip this. All right. So we said that if I had some number that was raised to the negative n, then that was the same thing as saying 1 over x to the positive n. We agree? Okay. So then if I do this the other way, if I say 1 over x to the negative n, well, there's a long way to do this, or there's a short way to do this. Okay? The long way to do this is to say, well, that's 1 over x to the positive n. And when we are dividing a fraction, we're multiplying by the reciprocal to top and bottom, x to the n over 1. And so these cancel, and I'm left with 1 over x to the n, or 1 times x to the n over 1, which is just x to the n. Okay, are you with me? Let's make this a little bit less confusing. If I have x to the negative n, any number by itself as a fraction is over 1. Do we agree? So kind of that imaginary fraction line says, when we're talking about exponents, I can only have positive exponents in my answer. So I'm going to move this down to the denominator, and I'm going to make this positive. So what I have left in the numerator is 1. What I have in the denominator is x to the n. Okay? If I do it the other way, if I have 1 over x to the negative n, in order to make this exponent positive, I have to move this to the other side of the fraction line and make the exponent positive. So now I have x to the n over 1, which would just be x to the n. Okay? So if I look at some examples here, if we look at this, let's just assume that all of this is over 1. Now remember, in the numerator, I have two different things. I have a 7 times w to the negative 4 over 1. And we want to make this exponent positive. So we're going to take this and we're going to move it to the other side of the fraction line and make this positive. So now all I have left on top is 7, and what I have on bottom is w to the positive 4. Okay? The other way to look at this is right here. I have a negative 2 for an exponent in the denominator. I'm going to move this up to the top and make it positive. So I have nothing left on bottom, so I have negative 5k to the positive 2. Okay? Sir?
So on the one you'll have the 7 and then can you figure out that 7 and maybe equal.
That's right there. That's my answer. Okay? All right, you guys give this a shot. So I can go ahead and just take out this a to the 0 because this is 1. I'm going to move this b to the negative 2 to the denominator, make it b to the positive 2. I'm going to move this c to the negative third and move this to the numerator, make it c to the positive third. So now all I have left on top is c to the third. And on bottom, now I have d to the sixth, b to the second. You okay with that? All right. So, simplify these, and then we'll be done. All right, so we'll eliminate the r to the 0. We'll move this to the denominator, m to the third. So we have 2 over m to the third. We'll bring this over to the denominator, make it positive. We have 1 over 7r to the third. We'll move this to the numerator, make it positive, g to the fourth, h to the sixth. Okay, are we good?